A is the centre of a circle with the equation x squared minus 8x plus y squared plus 10y plus 1 equals 0. The points P, Q and R are points on the circle. The lines L1, L2 and L3 are tangents to the circle at those points respectively. The line L2 intersects line L1 at B and line L3 at D. Part A, find the centre and the radius of this circle. So let's take this equation and do some completing the square. So focusing on the x parts first of all, x minus 4 all squared minus the 16. Now let's focus on the y part. We've got y plus 5 all squared minus 25. Let's not forget about that plus 1 equals 0. Taking those constants to the right hand side, we get 40. So the centre of this circle is 4 minus 5, that's point A. And the radius of the circle is root 40 or 2 root 10. So that's part A done. Part B, given that the x-coordinate of Q is 10, okay, so we know that this point here is 10. We don't know its y-coordinate yet. And that the gradient of AQ is positive. Okay, so the gradient of this line here is positive, which makes sense from the diagram. Find the y-coordinate of Q, explaining your solution. Okay, well remember that point Q is on the circle, so it is going to obey this equation here. And I know that x is 10. So if I were to substitute 10 into that, 10 squared minus 8 times 10 plus y squared plus 10y plus 1 equals 0. So that's going to give me the equation y squared plus 10y plus 21. Factorising, so y plus 3, y plus 7. So either the y-coordinate is minus 3 or the y-coordinate is minus 7. So now I need to think which one of those is appropriate for point Q. Well, if I said that y was minus 7, that would be wrong, because then the line AQ, if this point here is minus 5 and this point here is minus 7, then that's gone down. And that can't be right if the gradient of AQ is positive. So it can't be minus 7, it has to be minus 3. So I'm going to ignore that because minus 7 is less than minus 5 and the gradient of AQ is positive. So we've got the coordinates of point Q. Right, part C of this question. Find the equation of the line L2. So the equation of this line here, which remember is a tangent to the circle at point Q, so I know it's perpendicular to AQ. So if I work out the gradient of AQ, which is the change in the y, so minus 3 minus 5 divided by 10 minus 4. So I get 2 over 6, which is 1/3. So, that's the gradient of my radius. So the gradient of the tangent is going to be the negative reciprocal of that. So that's going to be minus 3. I can now do y equals mx plus c. I know this line is going through point Q, so it's going through the point 10 minus 3. So the y coordinate is minus 3 when the x coordinate is 10. So C is going to be 27. So therefore, I've got the equation of my straight line, which is like that. And that's the answer to part C of this question. Right, I'm going to clear a little bit of space here because I'm going to need some more space for the rest of this question. So let me just get rid of this. Okay, part D. We're told that APBQ is a square. So let me mark that on. APBQ is a square. And we need to find the equation of L1. L1 is this. Now, I already know the gradient of that line because it's going to be perpendicular to L2, so it's got the negative reciprocal of the gradient I just found. Or you could say, well, it's just going to be parallel to this line here, so it's got the same gradient as the 1/3. So I know the gradient of this line is 1/3. I don't know its y-intercept yet, though. But I do know, well, I don't know the y-intercept. I'd like to know a point that this line goes through. The problem is I don't know what point P is, and I don't know what point B is. But we can work those out with some work with vectors. So I'm going to work out point B using a vector. I can do that because if I work out the vector from A to Q, from there I've gone across 6 squares from the 4 to the 6, from the 4 to the 10, and I've gone up 2 squares from the -5 to the -3. So this is the vector 6, 2. And I know that this vector is perpendicular to that. So the vector from Q to B, well, that's going to have to be, I'm going back, I'm going 2 squares in the negative x direction, I'm going up 6 squares in the positive. So let me just try and explain that one more time because my diagram's a bit messy here. What I'm saying is that from here to here I've gone across 6 up 2. So therefore from here to here I'm going to go back 2 up 6. So that allows me to work out the coordinates of point B, because I know the coordinate of Q there. So if I subtract 2 from the x coordinate there, I get 8, and if I add 6 to the y coordinate, I get 3. So I can now say that the y coordinate is equal to 1/3 times the x coordinate plus c. So 3 equals 8 over 3 plus c. 3 minus 8 over 3, which is 1/3. So I have now worked out the equation of L2. Oops. Right, let's now move to the last part of the question. Where we are told L1 intercepts the y-axis at point E. So, yeah. And we know that point is the y-intercept of L1, so we know that is the point 1/3 from there. Question says, find the area of EPA, triangle EPA. So let me mark that onto my diagram. EPA, E to P to A, like that. So I want to work out that area, the area of that triangle. I know that EP is the radius. So this is the 2√10 that we worked out at the beginning. And I know the coordinate E is the coordinate 0, 1/3. So I could work out the distance between A and E, this distance here, by doing the change in the x coordinates squared plus the change in the y coordinates. So the change in the y coordinates is 1/3 minus 5 squared, all square rooted, which gives me the square root of 40/9. Or that is the same thing as 2√10/3. I could now work this out. Hang on, let me just check that again. So we've got 4 squared. Apologies, I think I just mistyped that into my calculator. 1/3 minus 5, all squared, all square rooted, which is 20/3. Sorry, yeah, I typed that in wrong. So that's 20/3. I can now work out this short side of the triangle over here with a little bit of Pythagoras. So 20/3 squared. That's the hypotenuse squared. Take away the shorter side, the 2√10 squared, all square rooted. And that gives me the 2√10/3. So that is the short side of this triangle. And now I can do half base times height. So the base of this triangle is 2√10/3. The height of the triangle is 2√10. And so that gives me the area of 20/3. And we're done.